Welcome back, everyone, for another daily deep dive into AI. Today, we'll be taking a look at some of the most interesting papers published on the ArXiv preprint server.
We've got a great selection today.
Yeah, we've got over 40 new publications covering a really wild range of topics.
Absolutely.
Everything from hardcore math and statistics to some really cool applications in healthcare, robotics, and even dealing with some ethical dilemmas in AI. Should be a great time.
Yeah.
Let's start with something that I think a lot of our listeners might find pretty relevant to their own lives. Generalized factor neural network model for high-dimensional regression. It's a mouthful.
Sure.
But basically, it's dealing with the always exciting and sometimes terrifying world of financial markets.
Yeah.
You know, how difficult it can be to try to predict stock prices or what's going to happen with ETFs.
Right.
Well, this research is really interesting because it takes this kind of combined approach of using neural networks, which are all the rage these days, but combining it with some more classic statistical methods to get a better grip on how these markets actually behave.
And what's really interesting about this is that they're applying it to try to predict changes in equity ETFs, which, as you know, a lot of these ETFs have pretty complicated structures. They hold, dozens or sometimes even hundreds of different underlying assets.
Right.
And this model is particularly good at handling those sort of multi-layered, hierarchical data relationships.
Yeah, it's really impressive to see AI getting better and better at untangling these really complex financial relationships.
Absolutely.
And speaking of complexity, another thing that really jumped out at me looking at several of today's papers is just the challenge of dealing with limited data. Imagine you're a researcher. You're trying to analyze a data set that has thousands of variables, but you only have a handful of observations.
Right.
It's like trying to solve a jigsaw puzzle with, 90% of the pieces missing.
Yeah, it's a tough one.
It's got to be a huge roadblock for a lot of AI researchers.
Absolutely. And one paper that tackles this head on is it's called Robust High-Dimensional Mean Estimation with Low Data Size and Empirical Study.
Catchy title.
Yeah, and basically what they're doing is comparing a bunch of different algorithms to see how well they can perform when you just don't have a lot of data to work with.
Okay, so they're trying to find ways to squeeze as much information as possible out of those limited data sets.
Exactly. It's like using AI to find a needle in a haystack.
All right, let's shift gears a little bit and talk about something else that I always find fascinating, deep learning architectures.
Okay.
One paper that really caught my eye was From Deep Additive Kernel Learning to Last Layer Bayesian Neural Networks via Induced Prior Approximation. Now, I know that's a mouthful.
Yeah.
But I think the underlying idea is actually pretty elegant. They're taking two really powerful AI techniques, deep kernel learning and Bayesian neural networks.
Right.
And they're finding a way to bring them together.
So you can almost think of deep kernel learning as this sort of master pattern recognizer. It's really good at finding those hidden structures in data.
Okay.
But Bayesian neural networks, they bring this sort of element of uncertainty awareness. They're not just spitting out a single answer. They're giving you a range of possibilities and a measure of how confident they are in each one.
So you get a more nuanced picture of what the AI is actually thinking.
Exactly. And by sort of merging these two approaches, the researchers are hoping to create models that are not only more accurate, but also more interpretable.
So we can actually understand why the AI is making the decisions that it's making.
Exactly right. We're lifting the curtain on that black box of AI.
I like that.
Yeah.
Another paper along these lines that I found pretty intriguing was one called A Power Transform. It seems to be all about finding these hidden connections between these seemingly different concepts in AI.
This one's really fascinating. They're proposing this single mathematical function that can be used to connect things like loss functions, which are used to train AI models.
Okay.
Kernel functions, which are used in things like support vector machines.
Right.
And even the activation functions that are used in the individual neurons within a neural network.
Wow, so it's like finding some kind of universal translator for the language of AI.
That's a great way to put it. It really could change the way we think about and develop these models in the future.
Okay, so we talked about some of the more theoretical stuff. Now let's get down to brass tacks and talk about some real-world applications.
All right.
One paper that stood out to me was Robust Partial Label Learnings by Leveraging Class Activation Values. And this one is really interesting because it's tackling a problem that anyone who's ever worked with real-world data knows all too well, which is messy data.
Think about it. You're training an AI to recognize, let's say, different breeds of dogs.
Okay.
And you're using images that have been labeled by humans.
Right.
But what happens when different people disagree on what breed a particular dog is?
Yeah, that could cause some problems.
Absolutely. It can really throw the AI during training. So this research is all about making those AI models more robust to these inconsistencies in the data labels.
So they're trying to teach the AI to be a little bit more skeptical.
In a way, yeah, it's about training the AI to not take every label at face value, but to really look for the underlying patterns in the data, even when the labels are a bit fuzzy.
It's like teaching the AI to think critically.
Yeah, exactly.
Another paper that caught my eye that's dealing with real-world stuff is assessing the impacts of tradable credit schemes through agent-based simulation.
All right.
This one dives into the world of urban planning and policymaking.
Yeah, so imagine you're a city planner and you're thinking about implementing something like congestion pricing to try to reduce traffic in the city center. Well, how do you know what the impact of that policy is going to be?
Right.
Will it actually reduce traffic? Will it just shift traffic to other areas?
Uh-oh.
What about the economic impacts?
Right. Are people going to be priced out of certain areas?
Exactly. Well, that's where agent-based simulation comes in. You can create these virtual models of the city with thousands of simulated agents, little virtual people,
Uh-huh.
each one making decisions based on, their own individual needs and preferences.
Wow.
And then you can use AI to run these simulations, tweak different parameters like the congestion pricing scheme and see how it affects things like traffic flow, pollution levels, people's commutes, all sorts of stuff.
That's amazing. It's like a virtual laboratory for city planning.
It really is. It has the potential to really change the way we design and manage our cities.
It's like SimCity, but with real-world consequences.
Yeah, exactly.
That's pretty cool.
Yeah. We've been talking a lot about AI's impact on things like finance and urban planning, but I think one of the most exciting areas where AI is really starting to make a difference is in healthcare.
Oh, absolutely. I couldn't agree more.
And one paper that really highlights this is Natural Health 2S, end-to-end high-quality multi-speaker lip-to-speech synthesis with differential digital signal processing.
Okay, another catchy title.
Yeah, they're not always great with the name, but the technology is really mind-blowing. Basically, they've developed an AI system that can translate lip movements into speech.
Whoa, that sounds like something straight out of science fiction.
It really does, and you think about the implications for people who have lost the ability to speak, due to illness or injury. This technology could give them their voice back.
It's incredible to think about the power of AI to really empower people in such a fundamental way.
Absolutely. And that's just one example. Another paper that caught my eye was from brainwaves to brain scans, a robust neural network for EEG to fMRI synthesis.
Okay, that one sounds intriguing. Tell me more.
So imagine being able to create really detailed brain scans from EEG data.
Okay,
Now, EVGs are much cheaper and easier to administer than FMRs,
right.
but they don't provide as much detail.
They're not as high resolution.
Exactly, but this research is using AI to basically bridge that gap.
So they're using AI to enhance the information that we can get from EEGs.
Exactly. You can almost think of it like taking a blurry photo and using AI to upscale it to a much higher resolution image.
That's amazing.
It's really cool, and for neuroscience research, this could be a game changer. It could allow scientists to study brain activity in much greater detail and with a much greater accessibility.
Wow, so it really democratizes the research process in a way.
Absolutely.
So we've been talking a lot about the positive side of AI, all the amazing things that it can do, but I think it's also important to talk about the potential risks, the possibility for misuse or unintended consequences.
Yeah, absolutely. With any powerful technology, it's important to proceed with caution.
Right.
And one paper that really highlights some of these risks is distraction is all you needed for multimodal large language model jailbreaking.
Okay, jailbreaking, that sounds a little ominous.
Yeah, it's not a great term, but essentially what they're talking about is finding ways to bypass the safety mechanisms that are built into these increasingly complex AI systems.
So it's like hacking the AI.
In a way, yeah, and specifically they're looking at multimodal models, the ones that can process both text and images.
Okay.
And they found that by introducing carefully crafted distractions into the visual input, you can actually disrupt the model's understanding of the relationship between those images and the text that's associated with them.
Oh, wow. So you can basically trick the AI into misinterpreting what it's seeing.
Exactly. And this could have some really serious consequences. It could lead to the AI generating harmful content or spreading misinformation.
Yeah, that's a sobering thought. It really highlights the importance of responsible AI development. We need to be thinking about these potential vulnerabilities from the get-go.
Absolutely. Security can't be an afterthought. It needs to be baked into the design process from the very beginning.
Along similar lines, there was another paper that caught my eye, Relearn, Unlearning via Learning for Large Language Models.
Yeah, this one's fascinating too.
And this is all about trying to make AI models unlearn specific information.
Yeah, so it's almost like hitting the delete button on certain parts of the AI's knowledge.
Okay?
Now, this is obviously a very complex process, but the goal here is to address some of the concerns about privacy and bias.
Oh, I see. So, if an AI has been trained on data that contains sensitive personal information, or if it's picked up some harmful biases from its training data,
Right.
we might want a way to make it forget that information.
Exactly. And that's what this research is exploring. How do we do that responsibly and effectively?
Wow. I mean, this whole episode has really been eye-opening, just the incredible breadth and depth of AI research. We've gone from talking about financial markets to brain scans to ethical considerations. It's really mind-boggling.
It really is, and it's moving so fast. It's hard to keep up, but it's also incredibly exciting. We're just scratching the surface of what AI can do.
We've seen how AI is being applied in so many different fields. But what about its role in creativity? Can AI be an artist?
That's a great question, and one that researchers are actively exploring. One paper that caught my eye was Step Video T2V Technical Report, The Practice, Challenges, and Future of Video Foundation Model.
Okay.
And it dives into this really fascinating world of AI-generated video content. Imagine being able to create realistic videos just from text descriptions.
So you're telling me I could write a screenplay, feed it to an AI, and it would spit out a movie?
Well, not quite a full-blown movie yet, but we're getting closer. These AI models are being trained on massive data sets of videos, learning to understand the relationships between visual elements, motion, and language. It's pretty remarkable.
It sounds like something straight out of a science fiction movie studio.
It does, and the potential for creative applications is enormous. Filmmakers, animators, even everyday users could have access to this kind of technology.
It's really exciting to think about the possibilities, but it also raises some interesting questions about the future of human creativity. Will AI replace human artists?
That's a big question, and I think it's more likely that AI will become a powerful tool for human artists, augmenting their abilities and expanding their creative horizons.
Okay, so more like a collaboration than a replacement.
Exactly. Think about the invention of the camera or the synthesizer. They didn't replace human photographers or musicians. They transformed those art forms, and I think AI has the potential to do the same for video creation and many other art forms.
Yeah, that's a great analogy. It's about pushing the boundaries of what's possible. And speaking of pushing boundaries, another paper that caught my attention was Architecture, Dataset, and Model-Scale Agnostic Data-Free Meta-Learning.
This is where things get really interesting.
Yeah, what is data-free meta-learning?
Well, imagine AI systems that can adapt to new situations and solve new problems without us needing to spoon-feed them information. It's like teaching AI to be more independent and resourceful.
Okay, so instead of giving the AI specific instructions and tons of labeled data, we're teaching it how to learn on its own.
Exactly. It's like giving the AI a toolbox and the skills to build its own tools as needed. This kind of data-free meta-learning could really revolutionize how we develop and deploy AI systems in the future.
It's incredible to think how far AI has come in such a short amount of time. We've gone from simple rule-based systems to AI that can generate videos, understand brain activity, and even learn on its own. It's been an amazing journey.
And we're just getting started. AI research is moving at an incredible pace, and we're constantly discovering new possibilities and, of course, new challenges too. But I think it's safe to say that AI is not just a technological advancement. It's a force that's reshaping our world, influencing everything from how we work and how we create to how we understand ourselves.
It's definitely a topic that's worth keeping an eye on. Thanks for joining us on this deep dive into the latest AI research. We'll be back tomorrow with more exciting developments from the world of artificial intelligence. Until then, keep those algorithms humming.